Hello everyone, today I am here to analyze species diversity for data sets which we have with us or we have collected during our field visits. And I am sure that after this lecture you will be able to analyze your data sets which you have with you during this period of time when you are staying. First of all, we will calculate Shannon index. For Shannon index, we need a very simple data set. As you can see here, I have number of species in column 2 and number of individuals in column 3. In column 1, you can put order or family of belonging species. Shannon index expression, if you have remember, is H is equal to minus summation pi ln pi. So what we need here to calculate Shannon index, we need value of pi, and value of pi comes from n divided by n. We have n number of individuals here, so find out here n. You can use calculators because we will be in need of calculating log value. So capital N is coming 21. Here pi we need to calculate, which is what? Which is n divided by capital N. Leave one column vacant, then ln pi, and here pi multiply by ln pi. So pi will be calculated using small n number of individuals divided by total number of individuals. 6 divided by 21, which is coming 0.286. It is 0.238. Zero point zero four eight, 0.143, 0.19, 0.095. Take log of pi values. See, in the calculator you will find one option for log values, one for ln values, which means natural logarithm value. It is for 0.286 is 1.252. I am also using calculator. 1.252 minus 1.435 0.733 minus 1.945. 945 minus 1.66. Delete this, looking ugly. 1.66 and minus 2.35. Here we have to multiply pi values with log pi values. It is coming here minus 0.358, 0.342, minus 0.035, zero point 278, minus 0.316, minus 0.224. 0.224. Do summation of these values of this column. It is coming 1.552, 1.552. What we need here to calculating Shannon index summation pi login pi. We have got this value here. Just put this value here. As this is a minus value, use minus. As I told you that often Shannon values are being shown in the form of Simpson value. That's why I had left this column here. For the Simpson value, what is the formula? If you have remember, the formula is D is equal to 1 divided by summation pi square. See, pi we have here, just we need to do here square of this value. Square of this value is 0.534. 0.488. 0.219. 0.378. 0.436. 0.308. दिया क्रॉस चेक कर लेना कैलकुलेशंस को. do summation of this, because we need here summation value. It is 2.363. 2.363. This formula we had, and we got value for this 1 divided by 2.363. So it is coming 0.423. So either you put Shannon value as it is, or you can change to Simpson value. Both values will represent species diversity of a given area or given site. Okay. One more thing we can calculate here with these values which we have calculated in upper columns, that is the evenness, right? Because as we have used square of pi values to calculate Simpson index, we can use here Shannon value to calculate evenness. First of all, just recall the formula of Shannon value. Yes, it is E is equal to what? This weight A is equal to H divided by log S. This is the evenness. What we have here with us, Shannon value we have here minus 1.552, and what else we need? Log S. S is the number of species, so S we have here S, number of species is 6. It will give a value 258.7. This is next problem is to see richness. How to calculate richness of your data. So for richness, we have 3 indexes: jackknife, margleaf, and McNeil. The problem says if we have 14 observed species with total 10 quadrate which have been sampled and have 5 unique species. Among all those quadrates which have been sampled, then how to calculate richness? Jackknife we are calculating here. The formula for jackknife is S bar is equal to S plus N minus 1 divided by N. Close in bracket, then K. We know that S is total number of species, K are unique species which we have in the problem, and N is number of quadrates sampled, and data is over there S, K and N. 14 observed species, 5 unique species, and total number of quadrids have been sampled are 10. Just put this data in the formula. 14 plus 10 minus 1 divided by 10. Unique species are 5. Do calculation. It's very simple. You will get the richness. Even on this data, you can use other two indexes, Marleaf and Magnin. Next problem is to calculate similarity or dissimilarity. Suppose there are 20 species found in community 1. We have monitored 2 communities or 2 study sites. There may be 2 plots or 2 quadrids. So we have 20 species found in community 1 and 25 species in community 2. Between them, they have 5 species in common. Means 5 species, unique species are 5. What is the formula of similarity index? This formula is, if you have remember, S is equal to 2K, or you can write here C, whatever, community 1 plus community 2, or if you have community 3, whatever communities, whatever study sites you have monitored, you can put in this sequence. Just put the data here. Two into 5. In community 1 we have 20 species, 25 species. Calculate the value. It will give you similarity between different sites, different coordinates, different plots or different communities. If you are interested in calculating dissimilarity between number of study sites, number of plots, number of communities, just need to do one thing, minus this value, whatever you will get here from the 1. So 1 minus S. You will get here dissimilarity. Right? It's very simple thing. Even to calculate these indexes is very easy, very simple, and I hope after this lecture you will definitely calculate data which you have with you. You have a lot of data because you have visited many sites during your field visits. So during this time period you have to calculate species diversity, richness and similarity and dissimilarity indexes. These all will be your exercises for assessment. Whenever classes will be open, then you can come to me with these exercises, but on your true data set. Okay? Till yet? Bye-bye.